Okay, looking at lesson 25 again, Taylor approximating polynomials. With this video, we're going to look at example number 6. Example number 6 says, find the Taylor polynomials p sub 0, 1, 2, 3, and 4, p sub 0, 1, 2, 3, and 4, for this natural log of x function centered at c equals 0, okay? What we're visibly doing is we're trying to create polynomials that approximate this such that it's around this point. Now, what does that thing look like? Let's just go ahead and draw a real quick picture over here. Not that we need to, but just so that we understand what we're trying to do. There's my natural log function. There's c equals 1. Okay. I want a linear function that approximates it. I want a constant that approximates it. I want a quadratic, a cubic, and a quartic or power of 4 to approximate this particular graph. Okay. So, how am I going to do this? Well, I'm going to go ahead and keep this formula very, very close by. P sub n is equal to that stuff. Okay. Also remember that when I'm utilizing this P sub n, this is P sub 0. This whole thing next is P sub 1. Everything after that is P squared, and so on and so forth. Okay. So, what I'm going to do here is I'm going to go ahead very carefully, P sub 0, okay, is supposed to be equal to simply f of c. Okay, what is f of c? Well, that's equal to the natural log of 1, which is just 0. Okay, so p sub 0 is 0, because natural log of 1 is 0. Okay, p sub 1 is p sub 0 plus, what's the next piece of that? Well, the next piece of that is this thing right here. Okay, that is f prime of c divided by 1 factorial. 1 factorial. Okay, let me write the 1 in there. We're just going to ignore that big black block. Then we have x minus the c value. Okay, so p sub 0 is 0. The derivative function. Now, I'm going to have to go all the way through up to the 4th derivative, because that's what I need to plug in. That's not pretty. So what I'm going to do is, off to the side here, I'm going to go ahead and write a table of values. F of x is equal to the natural log of x. The first derivative of the natural log, the derivative of natural log is what again? 1 over x, or x to the negative 1. Okay, I write the negative 1 because it's going to be easier for me to find the next set of derivatives. What's the second derivative? Well, I drop the power, and I subtract 1 from the power. And the third derivative is I drop that power, so I get negative 1 times negative 2, which is a positive 2, x to the negative 3. Okay, and then I do the fourth derivative. Okay, you might want to write in parentheses a little 4 there to make it helpful. This is equal to, I drop the power, so negative 6, x to the negative 4. Now, I don't want the x's in there. What do I want? In my formula, I want the derivative at the value c. So, what I really want here is, what is f of c? Well, f of c, c being the value of 1, okay, natural log of 1 is 0, okay, and let me just start plugging this in. So f of, the first derivative at 1 is, 1 over 1 is 1. The second derivative at 1 is a negative 1 divided by 1 squared, which is a negative 1, okay. The third derivative at 1 is going to be a 2 times 1 over 1 to the 3, so that's actually just going to be a value of 2. My fourth derivative at 1 is going to be plugging in a 1 here, which is just going to be a 1 and a negative 6. Okay. If you're very careful, you might actually recognize a pattern that's occurring here. I'm not going to talk about it just yet, but there might be a pattern that you could see happening. Okay. So back over here, I now have all of the derivatives that I might need. Okay, this is all always divided by the factorial of the derivative power, and then I have x minus c. So I'm going to cross all these things out, and we'll rewrite them later. This is p sub 0, which is 0, okay, plus the first derivative over on my table is 1, so 1 divided by 1 factorial, times x minus c value is 1, and therefore this thing is 0 plus x minus 1, okay. This is p sub 1. I'm going to put that in a box. I'll put that one in a box, okay, because I need all of these. Now I need p sub 2, remembering that p sub 2 is technically p sub 1 plus the second derivative at c divided by 2 factorial times x minus c to the power of 2. Everything derivative, factorial and power all change from 1 to 2's. Okay, so this is equal to the x minus 1. Okay, plus the second derivative way over here is negative 1. So it's negative 1 divided by 2 factorial times x minus 1 to the power of 2. Again, just changing the c to be a 1. Hey, look, I'm done with the second degree Taylor polynomial. Okay, how about p sub 3? Well, p sub 3 is all of this junk, okay, p sub 2, plus the third derivative at c divided by 3 factorial times x minus c to the power of 3. Again, just that extra term. So this is going to be x minus 1, okay, minus x minus 1 squared over 2 factorial. Again, I move this negative to here. I move this on top, okay, plus the third derivative at c is a 2, so I'm going to go ahead and write that in. 2 divided by 3 factorial times x minus 1 to the power of 3. Okay, well, there's my third degree Taylor polynomial. Okay, let's do the last one. P sub 4 is equal to, remember, P sub 3 plus the fourth derivative at c divided by 4 factorial times x minus c to the power of 4. The fourth derivative is negative 6 at that value of 1. So I'm going to have this is equal to the x minus 1 minus the x minus 1 to the power of 2 divided by 2 factorial plus the 2x minus 1 to the power of 3 divided by 3 factorial plus, okay, a negative 6 divided by 4 factorial times x minus 1 to the power of 4. Now, if you see a pattern starting to emerge, great. If you don't, that's also okay. In time, we're going to need to get better at these when we start working in the next sections. But for right now, this is acceptable in terms of your approximating Taylor polynomials. Again, I have the first one 0. First degree is x minus 1. Second degree is this quadratic. Third degree is this cubic. And fourth degree is this particular quartic. Okay, you can multiply all this crap out, simplify these numbers, but honestly, it's not necessarily worth the work. Okay, in some classes they might require it for you. Again, in mine, you did the calculus work. Everything after that is honestly algebra. Leave it here. Okay, this is your fourth degree approximating Taylor polynomial. We've still got about 7 minutes left of this video. I'm going to go ahead and do number 7. Number 7 says find the infinite, okay, which technically isn't a thing, Maclaurin polynomial, specifically for f of x equals the cosine of x. Now, when I ask for an infinite Maclaurin, it means that it's going to be at, okay, x equals 0, or c equals 0, okay, the value that I'm plugging in for all of those c's, there, over here, okay, is going to be 0. Now, infinite implies that I should be working with a pattern, okay? So maybe I should try and determine that pattern. Well, the pattern is very clear here. It's a matter of recognizing the overall pattern. So what I'm going to do is this. I know that I'm going to need all these derivatives. So I'm going to look at f of x, and that's going to be the cosine of x. And then what I'm going to do is I'm going to start taking the derivative. Okay? If I create myself a table of values, maybe I'll see a pattern come up with this. Derivative of cosine, I believe, is negative sine of x. The second derivative is going to be the derivative of negative sine. Okay, the derivative of negative sine. Derivative of sine is cosine, so this is going to be a negative cosine of x. Then I have the third derivative of x. Well, the derivative of cosine, okay, is a negative sign, so it's negative negative, which is a positive sign. And you'll start noticing that once I get to here, the fourth derivative, okay, is circling back around to cosine of x. Okay. Well, what happens if I start plugging in my value c? So f of 0, the 0 of cosine is actually going to be a value of 1. F prime of 0, well, when I plug in 0 for sine, I get 0. The second derivative is a negative 1. Again, when I plug in 0 for cosine, I get 1, and then I negate it, so negative 1. The third derivative at 0 is going to be 0 because sine of 0 is 0. The fourth derivative at 0 is going to be a positive 1. I hope you see a pattern starting to emerge. The fifth derivative is going to go back to 0. The sixth derivative is going to go, again, 1, 0, 1, 0, negative 1. Okay, and so on and so forth. Okay, so you notice that every other term is going to have a 0 multiplication, and every other term, ignoring that case, is actually going to be negative, positive, negative, positive, negative, positive. Okay, so I have all my derivatives done. Let me go ahead and p sub n of x is equal to. And I'm going to go ahead and write out my actual setup. F of c plus the first derivative at c divided by 1 factorial times x minus c to the power of 1 plus my second derivative at c divided by 2 factorial times x minus c to the power of 2 plus, and then it'll be the third derivative at c divided by 3 factorial. And I'm sorry, I gotta move this for you. Okay. Times the x minus c to the power of 3 plus dot 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 all the way to the nth term. Now, what did I do? Where did I get this? I copied it straight from here. Okay, that's really where I got it from. Let me plug in the things that I've just evaluated, as well as all of the zeros for c, because we're doing this at c equals 0. So let me plug all that stuff in. P sub n of x is equal to 1, f of c is 1, plus 0 divided by 1 factorial times x minus 0. Wait a second. Wouldn't this whole term just end up being 0? I mean, 0 times anything is still 0, so that whole thing is 0. That whole first term is 0. Okay? Plus, the second derivative is going to be a negative 1 over 2 factorial times, and it's x minus 0, I'm just going to make it x squared. Okay? Plus, the third term. Isn't the third derivative way up here just 0? So the third term is just going to be 0. Plus, what would be the fourth term? Well, the fourth term would have a f4 derivative of c of 1. So I'm going to have 1 over 4 factorial times x to the power of 4. Fifth term, you guessed it, it's going to be 0 again. So I have 1 plus 0 plus negative 1, 2 factorial x squared, plus 0, plus positive 1 over 4 factorial x to the fourth, plus 0, plus the next one will be, now it's fourth, fifth, this should be x to the sixth. On the bottom should be the 6 factorial. And what should go up here? Well, remember, it alternates between 1, 0, negative 1, 0, positive 1, 0. 6 is negative 1. Okay. What's about the seventh term? 0. Eighth term, positive 1 over 8 factorial x to the 8th. Ninth term, 0. Plus, I go negative, positive. This one should be negative 1 over 9 factorial x to the 9th. Do you start seeing this pattern develop? Okay. Now, there might be an easier way to see this, to visualize it. I mean, up here, you could have run through p sub 0 is equal to, p sub 1 is equal to, p sub 2 is equal to, p sub 3 is equal to, p sub 4 is equal to, and that might help you develop the pattern a lot more efficiently. But it's a lot more writing. Okay. I decided to just do it all at once. P sub n of x is really equal to what? 1 minus x squared over 2 factorial, right? The negative can be moved over to here. It's x squared on top of 2 factorial. Plus a 0, I'm going to skip that. Plus x to the fourth over 4 factorial. Plus 0, I'm going to skip that. Minus x to the sixth over 6 factorial. I'm going to skip that. Plus x to the 8th over 8 factorial. Plus, wait, no, I'm sorry. It should be minus. Okay, and I'm sorry, this is 8. This should be a 10, not a 9. Remember, the odd powers disappear. This is x to the 10th divided by 10 factorial plus dot dot dot. This is the infinite Maclaurin polynomial for cosine.